All right, welcome everyone to this open house workshop. It is my pleasure to introduce our host today and also myself. So I am Swagtimus. I work for the Arbitrum Foundation as a developer relations evangelist, and this is part of the Open House Learn program, which is basically comprised of online courses that you guys have already been doing at a great pace, and also some online workshops, which we've also already done one of so far. And this is our next one, featuring Daniel from OpenZeppelin. And he's going to give a workshop today about unlocking high-performance Rust smart contracts on Arbitrum Stylus with OpenZeppelin. And with that being said, I would love to hand over the stage to you, Daniel, to get going with this amazing workshop, and wish you all the best with that.
So thank you, Swagtimus, for the great introduction. I am lead open source developer at OpenZeppelin, and I've been working on the Stylus smart contracts library from the very beginning. So let's talk about building high-performance Rust smart contracts for Arbitrum Stylus. So let's begin with a very simple question. So what is Arbitrum Stylus? So Arbitrum Stylus is an upgrade to Arbitrum technology stack that allows WASM smart contract execution. So before the upgrade was made, Arbitrum chains allowed only to execute EVM bytecode EVM smart contracts. And after the upgrade, we have additional WASM virtual machine that is co-equal to the EVM virtual machine. And that virtual machine allows us to deploy, execute WASM smart contracts. By WASM smart contracts, I mean every smart contract that can be compiled into WASM. We can build smart contracts in Rust. We can build smart contracts in C++, C, and any other programming language that compiles to WASM. These both virtual machines are called multi-VM concept, and those virtual machines are co-equal. They share the same persistent storage. They have the same priority. They can cooperate. They can call each other. I mean, any EVM smart contract can call WASM smart contract, and every WASM smart contract can call EVM smart contract. Additionally, that WASM virtual machine provides access to the blockchain information like chain ID, account balance, timestamps, blocks, headers, anything that is available on the EVM. How does it work? So basically, developers, users deploy smart contracts, and based on the bytecode, it is interpreted either by EVM or WASM virtual machine. When users send some transactions, the whole technology stack checks the contract headers to differentiate if it is EVM smart contract or WASM smart contracts, and use proper virtual machine. Thanks to Stylus, we have faster execution and lower gas fees. And this is because operations are much faster on WASM virtual machine. Additionally, thanks to Stylus, we have higher security for our projects or our protocols, because with Stylus, we have reentrancy disabled by default. In other words, when you build your own Stylus smart contract, you have reentrancy disabled. Of course, if you want to, you can allow reentrancy, but this is not recommended way unless you really need it. Now let's try to kind of introduce you to the technology stack around Arbitrum Stylus. And the first part, the first term, is Stylus SDK. So Stylus SDK is a set of libraries and tooling that allows you to build EVM-compatible WASM smart contracts. And the most popular one is, of course, the Rust Stylus SDK, and also Motsu one. And I will use that SDK in our workshop. The second tool that I'm going to introduce is Cargo Stylus. And Cargo Stylus is a command line tool that brings you all the features that you need to build Stylus smart contracts, deploy it, verify it, cache it, and any stuff that comes to your mind. The last but not least is a Nitro node. And Nitro node is an Arbitrum node that holds the multi-virtual machine. And during this workshop, I will use, for example, Nitro test node. Developers, of course, can use Nitro dev node. And there are Nitro nodes that are used for Arbitrum chains, of course. Now let's quickly go through the very small details of how to build our own very easy Stylus smart contract before diving into more technical aspects. So just to begin with, to begin the project, we are going to use Cargo Stylus command, Cargo Stylus tool with new command, and it creates for us a very simple project with counter example. And I'm gonna go quickly through all the most important files. So at first, Rust toolchain.tom. It contains all the information about the Rust version that we are using for our project and all the Rust components that are needed. Additionally, we have the cargo tom file. In this file, developers are supposed to specify all the Rust dependencies for the project, for the contracts. The great thing about Stylus is that developers can use any Rust library that can be built, that can be compiled into WASM. The most important file is lib.rs. In this file, developers are supposed to write their smart contract logic. So here is the file where the whole logic is stored. The last but not least is the main.rs file. This file contains some information and some instructions how to print the smart contract interface, but we will touch this this aspect later. Okay, so let's start with defining some storage around our very simple counter smart contract. As I previously said, that storage is defined in lib.rs file. And in order to define storage for our Stylus smart contract, we just need to write a regular Rust struct with a couple of macros. So the first Rust macro that needs to be used is storage macro. And this macro provides for us all of the code that is needed to both read and write to the persistent EVM storage. The second macro that we need to use for our smart contract is entry point macro. And that entry point macro provides for us all the code needed to interact with our smart contract on chain. Once defining our storage for the smart contract, we can use any data types that we do know from Solidity. Everything is available thanks to the Alloy primitives Rust library, and we can use any data type that we know, like storage, like unsigned integers, like addresses, like maps, strings, vectors, anything that comes to your mind. Having defined the storage for our very first counter smart contract, it would be great to write some logic for it. In Rust, we write logic for Rust structs in implementations block. We can have as many implementations block as we want to. And now let's take a look into the screenshot. So the first implementation block has a public macro. A public macro is a specific macro that exports all these functions from this implementation block to be available on the smart contract level. So all the functions like value, increment, decrement, these functions are callable via transaction. But for example, from the second implementation block, function like set value is not available to be called via transaction. Rest functions can return either value or result with success and error, depends on the context. Our Stylus smart contracts functions, of course, can panic as a Rust code can do. Additionally, thanks to the Rust Stylus SDK, we have access to EVM features like emitting an event, like checking the message sender, as you can see in set value function. I mentioned about events, I mentioned about errors. So let's check how users can define them. So both event and errors are defined with Solidity syntax inside Sol macro. So Sol macro is a Rust macro that comes from Alloy libraries, and this macro parses the Solidity code, creates Rust structure, and adds all the code that is needed to use on EVM compatible chains. There is one point to be mentioned for errors. So in Rust, you must strictly specify what kind of an error can be returned from a function. And let's, for example, imagine a Rust function, smart contract function, that can transfer some funds, and it may revert in so many ways. For example, an owner may have not enough balance. Additionally, the message sender may not have permissions to transfer those tokens, that balance. So basically, to enable each smart contract function to return as many errors as possible, and developers need to provide error enums. So an enum is a Rust component that enables you to specify as many possibilities as you want. And thanks to the Solidity error macro, there is a great binding between Solidity defined errors and our error enum. Now it would be great to learn how to deploy our very first Stylus smart contract And in order to do that, we are going to use Cargo Stylus deploy command. That command sends two transactions. So the first one is a transaction that posts the WASM code on-chain, and this is called deployment transaction. And the second one is called activation transaction. These transactions does some preparation stuff around the already uploaded WASM code to be available for the WASM virtual machine. Now I need to introduce, let's say, weird term for smart contracts, and that term is cache. And to give you at first proper introduction, let me tell you something. So the cost of loading WASM bytecode into our WASM virtual machine on Arbitrum chains takes a lot of time, which means that it consumes a lot of gas. So in order to fix this issue, the Off-Chain Labs team, the team that built the whole technology around Arbitrum, came up with an idea of cache manager contract. So cache manager contract is a smart contract that holds frequently used Stylus smart contracts in a cache. In order to have our Stylus smart contract in a cache, we need to place some bit with the Cargo Stylus tool, for example. Having our very first Stylus smart contract deployed, we would like to know how to interact with the smart contract. Now it's time to talk about the main.rs file. In this file, you can find only very first single one instruction, that is print ABI. After typing the command cargo stylus export ABI, the tool prints for us the whole Solidity interface of our smart contracts. Based on the interface, we know how to interact with our already deployed smart contract, and we can use any tool that we know from interacting with EVM smart contracts. Everything works as with Solidity smart contracts. Okay, we covered the very basics. And now let's talk about the Stylus smart contracts library that we've been working on at OpenZeppelin. The first part of the library is mostly all the standards that we have built for any other ecosystems, like for Solidity, for Cairo, for Stellar. Right now, in our library, you can find smart contracts with a bunch of different tokens. For example, ERC20 for managing fungible tokens, ERC721 implementation for managing non-fungible tokens, ERC1155 implementation, bunch of extensions for each token standard. Additionally, we have a great amount of access management smart contracts, like access control with some of the extensions, ownable two-step. Just to give better overview, access control gives you role-based access management to smart contracts. Also, we have some upgradability mechanisms like beacon proxy, UUPS proxy. We also have some smart contracts for finance, like vesting wallet. We also provide a lot of utilities like ERC165 for contract introspection. We also provide a bunch of helpers to interact with both ARP-OS and EVM precompiles. We also provide a bunch of storage structs, helpers, and stuff like that. Currently, we have two versions that we recommend to use, and those versions are v0.2. This is our stable and audited version. We also have v0.3 release candidate. This candidate right now is undergoing a security audit, and you might expect the official audited v0.3 version in September. Now it's time to build an ERC20 token with OpenZeppelin Stylus library. I encourage you to scan the QR code to dive into the repository where I commit by commit showed progress, how to build ERC20 tokens with some extensions and how to interact with it. So let's dive into the code. So this is the repository that you saw the QR code, and let's check all the changes that I've made to have ERC20 token with a bunch of extension. So the very first commit does not matter because they are just initial commits, some cleanups. Let's start with adding OpenZeppelin Stylus as a dependency to our Stylus smart contract. So I added into the cargo DOM file OpenZeppelin Stylus release candidate. Also, I removed Stylus test feature from Stylus SDK, and I needed to do this because later I will show you testing with our own testing tool that does not use Stylus test tool. Also, I modified the export API feature to use the OpenZeppelin Stylus export API feature, and our feature enables Stylus SDK export API feature automatically. I removed all the Stylus tests from the counter, and also I modified the name for the smart contract. So right now we have the dependency added. Now let's build the pure ERC20 token with the OpenZeppelin library. So in order to do that, we need to import ERC20 struct and also ERC20 trait. And trait is kinda, for those who don't know, Rust traits are like interfaces for some logic. As I said, we need to define a structure that holds our smart contract. It holds the ERC20 structure. We have entry point macro. We have storage macro. And now we need to implement the logic for our smart contract. You can see public macro, and below the public macro, there is implements macro. So implements macro tells which interfaces will be available on the smart contract. So right now, we will export only the ERC20 interface for the smart contract, and we need to implement that interface for the smart contract. As you can see, the implementation is really easy and straightforward. It is just re-exporting all the functions from the ERC20 struct. That's it. We have ERC20 token built. Now let's add some extensions to our ERC20 token, and this extension will be burnable. So it brings the burnable feature. we need to just import the interface, the burnable interface. We need to add the interface to the implements macro, and of course, implement the interface in additional implementation block, of course, with the public macro. The next extension that we are going to include is the metadata, and it is more, let's call it, sophisticated one, because we will need to initialize the contract at first. So we need to import, of course, the trade and the structure, add the structure to our smart contract, add the new interface to our smart contract. And here you can see that I implemented a constructor for the smart contract. For those who don't know, a constructor is a specific function that is called during smart contract creation on chain. And the purpose of the function is to initialize properly the smart contract state. As you can see, in this implementation, we set both name and symbol for our ERC20 token. As you can see, we implemented all the metadata functions for the smart contract. And this is the second implementation block that I needed to add, because ERC20 metadata trade interface requires to be ERC165 compatible. So we need to export additional function supports interface. This is kind of straightforward. Of course, we need to include it in implements macro. Right, so we have our token implemented. We added some extensions, but we would like to add right now token minting feature with some restricted access. We want to make the token minting feature that way that only owner of the smart contract can mint tokens. So we can import from the OpenZeppelin Stylus library the ownable component, ownable struct, and its interface, add it to our smart contract, to our workshop smart contract, add an interface to the smart contract, initialize the ownable component properly in the constructor. You can see that the signature of the constructor has changed, and this is because ownable constructor can revert with some errors. In other words, once you deploy with constructor with bad parameters for the constructors, that transaction will revert. And this is how we can add the minting feature. So we just need to add the mint function. At first, we use ownable component to check if the message sender is the owner of the contract. And once it passes, we just call mint function to mint specified amount of tokens to a specified recipient. Of course, we need to export the interface for ownable by exporting the all ownable functions. Great. We have implemented our contract, but right now I need to mention about some limitation that each developer must remember. So the limitation is each WASM smart contract cannot exceed 24 kilobytes. And we figure out that with using some of the Rust nightly features, we can optimize the WASM binary to reduce the smart contract size. And for in order to achieve this, I modified the toolchain to use nightly version. Now, I would love to show you how to interact with the smart contract, and with in order to show you how to interact, we have an example that will invoke, call, query some functions, and of course will send some transactions from the Rust code. We use Ethers library. It is a Rust library that is used for interaction with EVM blockchains. In order to interact with our smart contract, we need to define its interface. As you can see, this is the Solidity syntax defining the interface of our smart contract. Of course, some logic about wallet creation, connections to the Arbitrum node, and this is the logic for interaction. So in this example, we will call the name function from the ERC20 metadata extension. We also will query the initial balance of our wallet. Then we will mint some tokens for us. And also we will check the final balance after token minting. And in the end, we will assert that the final balance is equal to the initial balance plus the minted amount. So right now, I have the Nitro test node up and running. I need to count the account to have gas to pay for the transactions. It's done. And now let's interact with the smart contract. All the instructions you can find in the README for our workshop. I will skip the very first, and we will focus on smart contract building, deploying, and running our example. So at first, we will use cargo stylus check command. This command checks if the stylus smart contract can be built if it does not exceed the WASM size. So as you can see, the smart contract built, it does not exceed it's 20.5 kilobytes. So we are good to go to deploy it. Now I'm going to build the optimized smart contract with the nightly features. It's already built. And now I'm going to deploy the contract. I think right now it's better visible. So this command looks sophisticated, and let me walk you through it. So -e, it stands for the RPC URL for the node that we are going to interact with. Private key, it tells that I'm supposed to use a specific private key. This is the recommended way to interact with the blockchain. It's done only for the workshop purpose. You should not store your private keys in environment variables. Additionally, in order to use stylus constructors, you need to specify the WASM file. Also, you need to specify the deployer address at the current Arbitrum chain. So deployer address is the address of Stylus deployer smart contract that calls the constructor on your smart contract. Additionally, you need to provide the constructor signature. So it tells what is the function name and what are the types of the parameters for the constructors. The last argument for the cargo stylus command is constructor args, and this is the list of arguments that we are passing to the constructor. So this will be the name, Stylus ERC20 workshop. The symbol will be MTK, and the owner of our smart contract will be this address. So let's execute it. As you can see, it has been executed. We can see deployed code address here, and also we can see deployment transaction hash. Also, Cargo Stylus recommends us to store our smart contract in cache. So let's do this. I'm going to send the Cargo Stylus cache bit command with the already deployed smart contract address and private key, not recommended way, but only for workshop, just to sign the transaction. Okay, the transaction has been sent. You can see the transaction hash. And now we should go to execute our example. So at first, it printed for us our wallet address that we use for the example. It queried the token name, and it is Stylus ERC20 workshop that we passed as a style for the Stylus constructor. It queried the initial balance. Also, it printed for us the transaction receipt for the token minting. We also got a confirmation that the transaction was successful, and it queried the final balance that is updated. And that's basically it for our ERC20 token example. Let's go back to the slides. Now, let's talk about assuring proper quality and security of our contracts. And let me introduce the tool that we also built at OpenZeppelin. The tool is called Motsu. Motsu is from Japanese word, which means to hold in English. And this is the tool that we built in the very beginning of our library, a lot of time before the Stylus test was built by the Off-Chain Labs. And thanks for Motsu, we can write unit tests for smart contracts. So Motsu provides both EVM and WASM emulation for our Rust smart contracts in a way that we can interact with the smart contracts as we call just regular Rust functions in tests. Of course, we can kind of prepare some environment for our test scenarios, like setting chain ID, setting timestamp, like you can see here. Additionally, we can not only send a transaction as an Alice, Bob, or any other address, and also we can send some tokens with the sender and proxy value. Motsu also supports calling cross-contract calls, which is a great feature. Of course, with Motsu, we can assert that some of the events were emitted or not. We can also check if proper errors are reverted or not. And let's check how we can use Motsu for our ERC20 token implementation. So to use Motsu in our contract, in your contract, you just need to import Motsu as a dev dependency to be available only for tests. And you can write unit tests inside tests module. You need to import everything from Motsu Prelude. And you can write your test in a way that you would write any other Rust unit test. But you need to use Motsu test macro. That macro provides you all the emulation preparation for the smart contract. For each test case, we must specify which contract are we going to test. In this case, it is ERC20 workshop, and the contract for testing purposes needs to be wrapped into the contract struct from Motsu, and we also need to specify all the addresses that we are going to use in our unit testing. Now let's check how it works. Basically, at first we are going to test if constructor properly sets all the values. So what are we doing right now is we just calling a constructor as Alice, and we expect this call to be successful. After that, we check if all the values are properly set, which is token name, token symbol, token decimals from the metadata extension, and also owner from the ownable extension. It must match all the values that we provided in the constructor. As I said, we can also assert reverts with Motsu, and this test shows us how to do this. So in this scenario, we are trying to transfer some amount of tokens, but we don't have sufficient balance. So this is the action that we are going to test. It should return an error, and then we can assert that the error that we got is equal to the expected error, which is ERC20 insufficient balance. Motsu also supports state revert. So after the revert with insufficient balance, we should have the proper initial balances for both Alice and Bob. Also, we can assert Rust panics with Motsu. The showcase is that ERC20 token follows the total supply. So to exceed the total supply, we must mint the maximum value for unsigned integer plus 1. So at first, we minted a single one token. It should pass. But then we try to mint the max value, and we expect the function to panic. Also, we can test the positive scenarios, just a regular transfer. So we need to, of course, initialize the contract, the balances, we need to send the transfer function from Alice to Bob. We can assert that the result is a success, and we can check if the balances are properly updated or not. So Ali's balance should be less, Bob's balance should be higher, and also we can assert that the event has been emitted. In order to run test, we just need to use cargo test. It's regular Rust test invocation. That's it. That is how Motsu works. That is how you can write unit tests with Motsu. So let's go back to our slides. Wizard for Stylus. At OpenZeppelin, we have a UI tool called Wizard, and this is a UI tool that enables you to kind of configure your smart contract by choosing the token extensions that you want to, and we have the tool prepared for many ecosystems like Solidity, Cairo, Stellar, Stylus. Stylus is an interesting one for us. So right now we support ERC20, 721, and 1155 tokens. We can specify the name for our token. As you can see, the name has been updated. We can also add some extensions. As you can see, the burnable has been added. We can add additional like permit. We will be adding more extensions in the future. You can set the security contact into the smart contract. You can set the license to be added into the code. After that, you can just either copy the code prepared by the wizard's contract, or just download the code. That is very nice addition when you don't want to build the contract by yourself, but have everything prepared in just a couple of clicks. Now let's talk about the second part of the library that brings great features and power of Rust and Stylus, and this is the crypto library. In our crypto library, you can find our own implementations of big integers that is optimized for WAS execution. You can also find some elliptic curve primitives like short wire struts and twisted Edwards models. You can also find final fields library, also optimized for the WAS environment. You can find Pedersen hash, right now only started instance, and many instances of Poseidon hash. You can find and use ED 25519 signature scheme. Of course, you can find some Merkle tree verification mechanism, and the versioning is the same as for the Stylus smart contracts library. So the stable one v0.2 and currently audited v0.3 risk candidate 1. Now let's dive in another showcase. We will build a Stylus smart contract that uses our crypto library, and we will add Poseidon hashing to the smart contract. So you can scan the QR code. Also, I shared all the links to the open house channel on Discord. So let's check the new repository. And I will go quickly only through the one commit. because it brings all the features in a single one commit. Yeah, so at first I added the OpenZeppelin crypto dependency risk candidate version with a feature ruint. This feature adds a simple conversion between alloy primitives and our big integers. And now this is how developers can define their own smart contracts using our OpenZeppelin crypto library. So usage of our integers, final fields, of course, imports of the Poseidon hash, and parameters for the Poseidon hash. Developers, of course, need to write a structure for the smart contract with entry point macro, storage macro, and developers need to implement the hash function just by using the OpenZeppelin library, just by creating a hasher, adding inputs to the hasher, finalizing the hash, and returning it to the user. This is how build a smart contract with Poseidon hash using our library. And now let's talk about the power of Rust and Stylus that is kind of provided, enabled by our library. We talked about the Poseidon hash implementation, and this implementation, of course, uses our own big integer implementation. Many was optimizations, attitudes like using some different integer types, like using function inlining and joining hot loops, using some was optimization tools, and we did some benchmarks, and the results that we get are amazing. So we benchmark the pure Solidity implementation of the Poseidon hash. We also benchmark Yule implementation, which is really hard to read, maintain Solidity assembly code. And of course, we benchmark our Poseidon implementation from OpenZeppelin crypto. And our implementation is more than 18th time faster than pure Solidity implementation, and almost 2 times faster than the assembly implementation. And it is super easy to read, maintain, and use. So just to summarize, Stylus is a great fit for the solutions that we have complex Rust, complex algorithms, sophisticated algorithms, a lot of computations, and stuff like that. Another use case that quickly can come to mind is some stuff around Uniswap before hooks. And one of the example showcase can be building own pricing model, custom pricing curve. So there is a well-known audited Solidity hook template. And from the template, we can call our Stylus implementation that we can build by ourselves with the pricing model. So in the template, we can just call the Stylus smart contract that you can implement with the sophisticated algorithm just by the Solidity interface, as we would call any other Solidity contract from that Solidity template. Another use cases that developers may want to build with Stylus can be any stuff around zero knowledge proofs, like on-chain verification. Another use case may be some advanced DeFi instruments, some advanced DeFi algorithms, anything like that. Additionally, developers may want to optimize existing solutions on Arbitrum chains with moving the on-chain logic from Solidity to Stylus and call the Stylus smart contracts from the Solidity ones. Just to summarize, we have endless possibilities for building projects with Stylus. And if you are about to choose between Solidity and Stylus for some great computation, sophisticated computation, you should always choose Stylus. That's it from my side. Thank you so much for listening. Yeah.
Awesome. Thank you, Daniel, so much for walking us through that. That was amazing. Thank you, everybody, for tuning in. If you have questions for Daniel based on this workshop, feel free to join the Arbitrum Discord, and Daniel will be available for some time there to answer any questions related to what was presented in this workshop. And with that being said, if you haven't registered for Open House yet, go to openhouse.arbitrum.io and sign up for the upcoming Buildathon. And I think this workshop has been great preparation for that. So thank you everyone for tuning in. Thank you, Daniel, so much for presenting. And we are going to wrap it up now and end the stream. Thank you so much.
Thank you. Bye-bye. Enjoy building with Stylus.